Hey guys, welcome to our channel. This is Gurjab and we are continuing the second chapter of calculus, which is applications of derivatives, and the first topic of today's video is rate of change of a function or of a quantity. So we know derivative, say y is equal to fx is a function, we say dy by dx is derivative of y with respect to x. We can also read it as rate of change of y with respect to x. So rate of change of a quantity is just another way to read derivative of that quantity with respect to x, and if I have to write rate of change of y with respect to x at x is equal to c, I'll write dy by dx at x is equal to c. Another important point, if I'm given that the rate of change, that is dy by dx, is increasing, it implies dy by dx, the value of dy by dx will be positive. And if I'm given that the rate of change is decreasing, implies the value of dy by dx will be negative. So we are cleared on the basic points. Let's look into some examples. Now in this example, we have to find the rate of change of area of a circle with respect to r. We know area of the circle is given as pi r square. Area is equal to pi r square. Clear? We have to find the rate of change of this area. So dA by dr with respect to r will be equal to dr of pi r square, which is equal to pi constant बाहर आ जाएगा dr of r square, which is equal to 2 pi r. This is the rate of change of circle with respect to r, but we have to find its value at r is equal to 5 centimeter. So at r is equal to 5 centimeter, we get dA dr is equal to 5 pi 2 pi r की value 5, which is equal to 10 pi centimeter square per second. Okay. In this example, we are given the length x of a rectangle is decreasing at the rate 3 centimeter per minute. The length x is decreasing at the rate 3 centimeter per second. So dx by dt is decreasing, means its value is negative of 3. Second, width y is increasing at the rate 2 centimeter per minute. So dy by dt will be equal to 2 positive. We have to find perimeter and area of this rectangle at x is equal to 10 and y is equal to 6. So perimeter is given as 2 into length plus breadth. So rate of change of perimeter will be dp dt is equal to 2 d dt of x plus y. दोनों एडिशन में दोनों का डेरिवेटिव क्या हो जाएगा, साथ में अलग अलग. So 2 into d dt of x plus d dt of y. We know dx by dt की वैल्यू हमारे पास -3 and dy by dt की वैल्यू हमारे पास 2. So we get 2 into -3 plus 2, which is equal to 2 into -1, which is equal to -2 centimeter square per minute. ये आ गया हमारे पास rate of change of perimeter. Second is rate of change of area. So in case of area, we know area of rectangle is given as length into breadth. So dA ddt of A will be equal to d dt of x into y. Product rule, first function into derivative of second plus second function into derivative of first, which is equal to x d dt of y plus y d dt of x. We know value of x is equal to 10, d dt of y की वैल्यू हमारे पास 2 प्लस y की वैल्यू हमारे पास 6 and d dt of x की वैल्यू हमारे पास -3. So we get 20 minus 18, which is equal to 2, and hence the result. In this example, we are given that the total revenue in rupees from sale x of a product is rx is equal to 13x square plus 26x plus 15. We have to find marginal value or marginal revenue when x is equal to 7. Marginal revenue is given as rate of change of revenue with respect to the total units sold. So units sold are x, so marginal value will be d by dx of r. Now revenue is 13x square plus 26x plus 15. So we get d dx of 13x square plus 26x plus 15, which is equal to d dx of 13x square plus d dx of 26x plus d dx of 15. Derivative of constant is equal to 0. So we get 13 into d dx of x square. Derivative of 26x is equal to 26, and derivative of x square is equal to 2x. So we get 26x plus 26. Now we have to find its value at x is equal to 7. So marginal revenue when x is equal to 7 will be given as d dx of r at x is equal to 7, which is equal to 26 into 7 plus 26, which is equal to 182 plus 26, which is equal to 208, and hence the solution. Now the next topic is increasing and decreasing functions. For a function f, for a real valued function f whose domain D lies in an interval I, it is said to be increasing. This function f will be called increasing if for every x1 less than x2 we get f of x1 less than equal to f of x2, where x1, x2 lie in the interval I. Okay, that is how you find out if a function is increasing or not. Now a function will be called strictly increasing if for every x1 less than x2 we get f of x1 less than f of x2. The difference between increasing and strictly decreasing is this sign. This is less than equal to and this is less than. Now the function will be called decreasing if for every x1 less than x2 we get f of x1 greater than equal to f of x2, and it will be called strictly decreasing if for every x1 less than x2 we get f of x1 greater than f of x2. Now in all of these cases x1 and x2 will belong to I. For example, let's say we have a function f of x is equal to 7x minus 3. We have to prove that it is strictly increasing. So suppose x1 is less than x2. Now multiplying both sides by 7 we get 7x1 less than 7x2, and subtracting 3 from both sides we get 7x1 minus 3 less than 7x2 minus 3. Now this is f of x1 and this is f of x2. So we started with x1 less than x2, we reached f of x1 less than f of x2, implies f of x is strictly increasing. Now there's another method to find out if a function is strictly increasing or strictly decreasing. For that, if a function f is continuous on a closed interval ab and differentiable on open interval ab, then that function will be called strictly increasing if f dash x is greater than 0, and will be called strictly decreasing if f dash x is less than equal to 0, and if f dash x becomes equal to 0, in that case the function is called constant. Now let's look into some examples. Now there's another method to find out if function is strictly increasing or strictly decreasing. For that, if f is a function which is continuous on closed interval ab and differentiable on open interval ab, continuous in closed and differentiable in open, okay, then this function will be called strictly increasing if f dash x is greater than 0, will be called strictly decreasing if f dash x is less than 0, and in a case if f dash x is equal to 0, this function will be called constant. Now let's look into some examples. Now we are given a function f of x is equal to 3x plus 17, we have to prove that this function is strictly increasing. By first method, say x1 is less than x2, multiplying both sides by 3, we get 3, x1 less than 3, x2, adding 17 both sides, we get 3, x1 plus 17 less than 3, x2 plus 17. This is f of x1 and this is f of x2. Now f of x1 less than f of x2 when x1 was less than x2 implies f of x is strictly increasing. Now by second method we have to find f dash x. F dash x will be d dx of 3x plus d dx of 17 which is equal to 3x ki differentiation 3 plus 17 ki 0, so it is equal to 3 which is greater than 0 implies f dash x is strictly increasing. Now in this example we are given that f of x is equal to sin x. We have to show that sin x is strictly increasing on the interval 0 to pi by 2, strictly decreasing on the interval pi by 2 to pi, and neither increasing nor decreasing on the interval 0 to pi. So first step, f dash x is equal to sin x का क्या होता है cos x. This is f dash x. Now we have to find its value on these three intervals. Now for every x belonging to 0 to pi by 2, the value of cos x is always greater than 0. So the value of f of x is always strictly increasing on the interval 0 to pi by 2. And also for every x belonging to interval pi by 2 to pi, the value of cos x is always less than 0. So this function will be strictly decreasing on the interval pi by 2 to pi. Now the last step, since this function is increasing, strictly increasing 0 to pi. Now we can divide this interval into two equal parts, 0 to pi by 2 and pi by 2 to pi. In the first part, this function is strictly increasing. On the second part, this function is strictly decreasing. So on a whole, this function will be neither decreasing and nor increasing. Now in this example, we have to find out the intervals in which x squared plus 2x minus 5 will be strictly increasing or strictly decreasing. So first point, f of x is equal to x squared plus 2x minus 5. So f dash x will be equal to 2x plus 2. Now we have to find its interval in which it's strictly increasing and strictly decreasing. So f dash x will be equal to 0 if and only if x is equal to minus 1. How? If x is equal to minus 1, we get minus 2 plus 2 which is equal to 0. Now this point x is equal to minus 1 divides number line into two parts, minus 1 minus infinity to minus 1 and minus 1 to infinity. In this first interval, this f dash x, that is 2x plus 2, will be less than 0 obviously. So in this interval, this function f of x will be strictly decreasing, and in this interval this function f dash x 2x minus plus 2 will be always greater than 0. So in this interval this function will be always strictly increasing. So end result, we get that this function f of x will be strictly increasing for x is equal to x greater than minus 1, and as the result. So guys, this was it for today. We'll be continuing this chapter in the next video. Till then, keep practicing.